Let's start with door first. As we all know, doors are the main component, may it be on a house or other kinds of building. It is an openable barrier at the entrance of the house, room, or other spaces that allow people, vehicle, and other goods to enter and leave. The door shutter, or what we always call door, is held in position by the door frame, the members of which are located at the sides and top of the opening doorway. Door is very important in any kind of building structure. Yes, for privacy and security, but also for many things like for the aesthetic view of our houses and other building structures, ventilation, noise barrier, connecting link between rooms, entrance and exit, and so on. Next is the window. Like doors, of course we also know windows. Windows are such a common feature of our homes that you may have never stopped to consider their importance. Nearly every building has some form of windows built into them. Windows provide our homes with light, warmth, and beauty. They make us feel less confined even in a small room. A window is like a small portal to the outside world that allows light, air, sound, and beauty to pass through. They enable the occupants of a house to enjoy the views of the neighborhood or locality. In addition, they serve to keep the house cross-ventilated. As such, houses with ample windows will seldom look gloomy or feel stuffy. Now, let's talk about hardwares. In the industry of construction, hardware refers to a group of metal equipment distinctively used for a structure's decoration, protection, and convenience. Building products are commonly the materials that support this process to make them work. Thus, it does not make any part of a building. Rather, they support them and make them work. It usually supports fixtures like windows, doors, and cabinets. Since we are talking about the estimation of the window frames, next to us is the example problem from the book. It says, low-cost housing project requires 50 pieces window frame as shown in figure 4 to 22. List down the materials needed for a fabrication. We will now proceed in computation. As what in the solution shows in number 1, the material is jump. In this case, we are computing for the length of jump first. 150 cm is the length of the jump and the other two 5 cms are the excess to be cut when the installation comes, so we need to add them in order to maximize our estimation. Now it's 160 cm multiplied by 2 pieces since we have a pair of jump in the window frame, and the answer will be 320 cm or 12 feet, and this is for our length. Next, since it says that the housing project needs 50 pieces window frame, what we will do here was basically multiply them all and divide it by 12 to get the board feet. Remember that the 2 times 6 or the 2 by 6 is the thickness and width in inches of the jump, as you can see from the illustration we had on a window frame, and the 12 feet was the computation we did a while ago for the length. So it goes like this: 50 pieces is multiplied by 2 inches times 6 inches times 12 feet over 12, and the answer will be 600 board foot. If you doubt it, you can go check and try it in your calculator too. Next is the computation for header and seal. The procedure of computing the header and seal is still the same as what we did on the jump. Just multiply them all and divide by 12 to get the answer. You can use these 50 pieces multiplied by 2 inches times 6 inches times 16 feet divided by 12, or 100 pieces since we are computing for header and seal. 100 pieces multiplied by 2 inches times 6 inches times 8 feet divided by 12, and the answer will be 800 board foot. Next is mullion. I don't know if the sign next to 100 is minus or just a dash. That's why I'm confused. But if we can see in the book and assume that it is just a dash and that dash means pieces, it tells us that we need to order 50 pieces of 2 inches by 4 inches by 10 feet, or let's just convert 10 feet to 3 meters of material for mullion, or we can also do 100 pieces of 2 inches by 4 inches by 5 feet, or just convert 5 feet to 1.5 meters. Last is the computation for transom. I also don't know if the book has some error or I just can't understand, but if we follow the 100 minus 2 inches times 6 inches times 8 board feet over 12, the answer won't be 800 board feet. And also, if we use the 2.20 plus 10, there will be some error too, because supposedly 2.20 meter is the 220 centimeter length of the transom, then will be added to 10 cm, not 10 meters, which is the excess. I will explain it more as we goes by, and I hope you understand because I'm not good at explanation. Here I provide some photos of how I've come up with the same answer as 800 board feet, which was stated in the book. So instead of using this one on the book, I did this instead. I fixed the sign and units that seems to be wrong. I hope I get it right and you understand it. I changed the sign from 100 minus 2 inches times 6 inches times 2.20 meters plus 10 meters to 100 times 2 inches times 6 inches times 2.20 meters plus 0.10 meters. The 2.20 meters you see in the illustration is the 220 centimeter length of the transom. It has the same length as the seal and header, while the 0.10 meters or 10 centimeter is the sum of 5 cm plus 5 cm excess each side of the transom. Now, let's proceed to computing it. First, add the one that is inside the parenthesis. 2.20 meters plus 0.10 meters is equals to 2.30 meters. Then convert it to feet. It is 7.55 feet, but we just rounded it off to maximize our estimation, so it's now 8 feet. Then lastly, we are to multiply it all now and divide the answer to 12, and that's it. We have the answer.
Estimating the material for fabrication of door frame is simply determining the size and length of the lumber that will accommodate the door panel. In ordering lumber for door frame, we have two options. It's either ordering 18 feet long for each door jamb and header, or a combination of 7 and 10 feet for jamb and header. For example, a 20 classroom building with 2 doors each specify 3 by 6 inches door jamb, and our task is to list down the materials needed for fabrication. As what I've said earlier, there are 2 ways or options that we can consider in ordering lumber for door frame. First is ordering 18 feet long for each door jamb and header. And to do this, first we have to determine the total length of the jamb. 14.5 plus 3.5 feet is equals to 18 feet. This is the total length of the jamb and the header added together. And the last step is determining how many pieces are we gonna order. Since there are 20 classroom and 2 doors, we have to order 40 pieces of 18 feet long lumber.
Let's talk about hardware this time. As mentioned before, hardware is a group of metal equipment distinctively used for structures decoration, protection, and convenience, and these materials are needed not only for decoration but also to strengthen and bind materials together in order for it to be safer. There are different kinds of hardware, such as bolt, screw, nail, and hinges. Bolts are a type of fastener, usually made from metal, that commonly comprises a head at one end, a chamfer at the other, and a shaft characterized by external helical ridge known as a thread. Bolts are typically used to hold materials or objects together, or to position objects. Typically, but not always, require a nut, which is applied via torque, while the bolt is held in place, or vice versa. Vibration or dynamic loads may loosen nuts, necessitating the issue of lock nuts, lock washers, or thread lockers, which can provide resistance to loosening. For lumber up to 5 cm thick, use 6 mm or 1/4 inch diameter. For 7.5 cm thick, or 3 inches, use lumber 10 mm or 3/8 inch diameter. For 10 cm, 4 inch thick lumber, use 12 mm or 1/2 inch diameter. Hole shall be 1.5 mm larger than the bolt diameter, unless snug fit is necessary. Always use washer under head and nut of your machine bolt. For carriage bolt, use washer under nut only. Use toggle bolt for attaching fixture to plaster wall. Use expansion bolt for fastening to masonry. And for outer exposure, use brass or cadmium plated finish bolt. Next is screw. Screw is another type of fastener, usually made from metal, that commonly comprises a head at one end and a point at the other, and a shaft shaped so that it can be turned into another material. In carpentry work, screw is sometimes used instead of nails due to the following advantages. 1. It is greater for holding power. 2. It is also neat in appearance. 3. There are less chances of injuring the material. And 4. It can be easily removed in case of repair. There are 3 shapes of screw point. 1. The gimlet point, which is used on wood and coach screw. 2. The diamond point. It is used when more driving is done before turning, as in drive and lag screw. And lastly, the conical point, which is the same as the diamond point. Screws are classified by gauge and length in inches. Each gauge has a variety of different lengths, which may be obtained up to 12 centimeters or 5 inches. When ordering screw, specify head shape or round head, finish or the brass, gauge number, and length from 2 to 5 centimeters. Square-headed lag screw comes in diameter of 6 mm to 25 mm, with its length from 4 centimeters to 30 centimeters. Nails are a basic type of fastener and have been used in construction in some form for hundreds of years. They are most commonly used for joining pieces of timber or for fastening materials to timber and are suitable when a screw is unnecessary. There are very variety of nails designed for specific purposes and finishes. They are manufactured in different lengths and gauges as required. Nails are usually hammered into place by striking them squarely on their head. By driving the nail in this way, it is less likely to bend or break. And nails must be of suitable strength, with a shank that is long enough to provide an appropriate attachment. Nails are held in place by friction, and some designs can include roughened, grooved, or twisted shanks to improve the hold. There are different lengths of nails. For general construction, use the common nail from 2 diameters to 60 diameters. For light construction household use the box from 2 diameters to 40 diameters. For interior rim, use the casing from 2 diameters to 40 diameters. For cabinet work furniture, use the finishing nail from 2 diameters to 20 diameters. For flooring construction, use the cut nail from 2 diameters to 20 diameters. For light work moldings, use wire brad from 3 16 inches to 3 inches. For heavy construction, use spike from 6 inches to 12 inches.